This is the third episode of our Chinmaya Algebra series, and if you haven't watched the first two, I suggest that you watch them first. For this video, we'll be looking at this problem involving a set of three variables, A, B, C, and P, Q, and R. The key here is to make use of this special formula involving the sum of three cubes and their product. We have A cubed plus B cubed plus C cubed minus 3ABC being equal to A plus B plus C times the square of A plus B plus C minus 3 times AB plus AC plus BC. I will not show how this was derived, but essentially one short way of proving this is by use of the properties of cyclic polynomials. So for now, we'll just accept these two equations as they are, or two formulas as they are, and we know this second one, the left side of the second one, to be equal to 4, as given by the fourth equation. We'll return to these two sets later on, but for now, first we consider the first three equations. If we add them, we get A plus B plus C equals 2 times P plus Q plus R. This is because we have two sets of P and two sets of Q and two sets of R when we add the expressions for A, B, and C. Next thing we want to find is the product of AB, AC, and BC. Because as of now, we already have the expressions for A plus B plus C and P plus Q plus R. I mean, there's a relationship already between them. So we'll proceed with A, B, A, C, and B, C. Again, we make use of the first two equations given as P plus Q and Q plus R. If we expand this, we get PQ plus PR plus QR plus Q squared. We can do the same for BC and AC to get something similar to this one. And if we add the three of them, we'll get A plus B or AB plus BC plus AC must be equal to P squared plus Q squared plus R squared plus 3 times the product of PQ plus QR plus PR. Now we have the relationship already for AB, BC, AC, and PQ, QR, and PR. The sad thing about this is we have introduced another set of variables or another set of expressions in terms of the squares of PQ and R. So an alternative step we can make here is to write this as P plus Q plus R squared plus PQ plus QR plus PR. From a coefficient of 3, this becomes 1 because the 2 went into the square of P plus Q plus R. So now we have these two sets of expressions here, A plus B plus C. I'll just put them aside, and this, okay, let's put this aside for now. And then delete the rest of the thing. So let's go back to the first two equations that we originally discussed. If we divide these two equations, we get A cubed plus B cubed plus C cubed minus 3ABC over 4 equals A plus B plus C over P plus Q plus R times A plus B plus C squared minus 3AB plus AC plus BC over P plus Q plus R squared minus 3PQ plus PR plus QR. It's quite a long one. Now we know that A plus B plus C is equal to 2 p plus q plus r. Therefore, the first ratio here is simply equal to 2. And then if we look at the numerator of the second factor, we get or express that in terms of p plus q plus r. Although for simplicity's sake, because it's quite long to write p plus q plus r every time, let's let that sum be just s. So this one becomes s squared minus 3 times ab plus ac plus bc. Oops, sorry. We made a mistake here because a plus b plus c is not s. It's actually 2s. So this one should be 2s squared. And then ab plus ac plus bc, if we go back to what we obtained earlier, that's equal to s. That's equal to 3 times s plus pq plus qr plus pr. And then if we expand that, this should be x squared. If we expand that, we get 4s squared minus 3s squared minus 3 times pq plus qr plus pr, which simplifies to s squared minus 3 times the quantity of pq plus qr plus pr, which, if you look closely, is equal to the denominator here. Therefore, therefore, the second factor here is actually just equal to 1. This first factor is 2, the second factor is 1. Therefore, the entire right side is actually just equal to 2. Therefore, the expression we're looking at is a cubed plus b cubed. I think it's hard to read this one, so let's change that to red. A cubed plus b cubed plus c cubed minus 3abc is equal to 4 times 2 is equal to 8. And that's our final answer. So I think there are alternative methods here, but that would involve expanding or multiplying longer expressions. So the greatest or the best solution, in my opinion, for this one would be to make use of these equations that we or formulas that we used. Hope you learned something today. Thank you for watching and subscribe for more content. Bye.